Hello everyone, I'm your instructor. My name is Maryum. Today I'm going to teach you Alkaloidal Drug Assay. So I will first of all tell you what are alkaloids. Alkaloids are actually first of all I will tell you about the introduction of the alkaloids. Then I will tell you preparation of the drug for assay and how we will prepare alkaloid for its assay or its chemical testing. And then I will tell you about the extraction of the drug, how we will extract alkaloids, and the procedure for following for the extraction, which are maceration, percolation, continuous extraction, and then I will tell you about the purification of the alkaloids, and I will also tell you about how determination of the alkaloids and the chemical and physical testing which will be done for alkaloid testing. So first of all, what are actually the alkaloids are? Are the alkaloids the basic carbon containing compounds with definite pharmacological activity? No, they do have pharmacological activity, but they don't have carbon containing compound. Second definition, they are the basically carbonyl containing compounds with definite pharmacological activity. No, they do have pharmacological activity, but they are not basic carbonyl groups. Then the third definitions, which is here, which are we are the alkaloid are saying that we are the basic nitrogen containing compound with definite pharmacological activities. Yes, these third definition is right. They are the nitrogen containing compounds with which are basically amino acid in nature, right? From the amino acids, they have amino acid and nitrogen compound structure. They have a definite pharmacological activities. Like here, the first example, which is coffee beans, and coffee beans have theophylline and other active ingredients like uh, theobromine, caffeine, theophylline, which have CNS stimulant effects, then morphine, which also have CNS depressant effect. It reduces pain, and then that is the more opium flour, and that's the chocolate, which is coca bean. Coca bean also have alkaloids in its structure, and then coffee is also have like alkaloids that are nicotine and caffeine and theobromine, which is the basic alkaloids present in the coffee beans. Then I will tell you the introduction for the assay. What is assay? How we will do the assay procedure? Okay, sorry for interruption. We will continue from here. Then we will perform qualitative and quantitative analysis. I think the recording is a bit interrupted. I will start from the assay. The determination of activity. What would be the activity which is performed by the alkaloid? Second, the potency, either it is a low potent or it's a high potent drug, or the alkaloid, or what is the strength of the alkaloid which is present in this specific plant. Either we will perform its assay on the absolute basis, or either we will compare either we will compare it with any standard preparation to determine its potency, its activity, and its strength. And secondly, we will perform its quantitative and qualitative analysis. Next ingredient is alkaloids, which component with specific therapeutic activity alkaloid is present in it. And what will be its quantity in the drug? Either it is like first of all determine that either the specific crude drug would have alkaloid or not. That would be its qualitative analysis, and then we will determine what is the quantity of that alkaloid per gram or per kg of that crude drug. That would be the quantitative and qualitative analysis, and then we will determine the amount of particular constituents of a mixture or its potency. So these are the basically alkaloidal drug assay which will be performed in our further slides. Then we will study what are alkaloids. Alkaloids are basically the organic compounds which are basic in chemical nature. They are basic in nature and they have nitrogen in their heterocyclic ring. And they are present in the vascular plants which have phloem and xylem for their transfer of their food and water and nutrients. And it's also present in some fungi, and It have marked physiological effect on the human body or any animal's body. Either alkaloid is present in the pilocarpine, either it is opium, either it is cinchona, it is ergot, either it is in vincristine, vinblastine, quinine, caffeine, colchicum, chloroquine, histamine, pilocarpine, cocaine, nicotine. All these are alkaloids, and they have physiological effect on human body or either in the plant body. They have any physiological effect on any part of the body. They are with any therapeutic effect. These are their inborn, and these are their definite property. Many alkaloids such as nicotine, which has CNS stimulant effect, quinine, cocaine, morphine are known for their poisonous or their medicinal attribute. The alkaloids are mostly potent drugs. Either they will have a poisonous effect or either they will have a medicinal effect. Then alkaloids are slightly or very soluble in water. They are poorly soluble in water, but they are good solubilized in the organic solvents like chloroform, ether, alcohol, isopropyl, IPA. They are more soluble in organic solvent than in water. But if we produce salt of alkaloids like morphine sulfate, it would be soluble in water. So salts of alkaloids are soluble in water, but almost insoluble in organic solvent. Because the salt of alkaloids are soluble in water, so that would not be soluble in organic solvent. But alkaloids are soluble in organic solvent, but they are not soluble in water. So this is something inversely. Like if we produce any salt of the alkaloid, that would not be soluble in the organic solvent, but it would be soluble in the water. So this is like solubility of nature of the alkaloids. So the process of assay is carried out by treating the drug with the soluble that would be soluble immiscible. First we will add any solvent that is immiscible in the alkaloids like water in the presence of alkali. What alkali do, it helps, it catalyzed, it increase this liberation of the alkaloids from its crude drug. It increased the extraction process of alkaloids from the crude drug to in the solvent, either it is an organic solvent. And alkali is basically acting as a catalyst in this reaction, in this chemical extraction process. Free alkaloids is dissolved by immiscible solvent from which it is removed by means of excessive diluted acid. We can free alkaloids by its immiscible solvent like water, and you can add diluted acid in it, which increase this activity. Then acid solution is then extracted with miscible solvent in the presence of alkali. If we add alkali, a surplus of alkali, it will form the salt of the alkaloid. That would be easy process for the extraction. Immiscible solvent is then evaporated, then because the solvent will be evaporated soon, and the salt of alkaloid or alkaloid would be weighed or determined volumetrically with the help of titration, and we will determine quantitatively with the help of volumetric titration analysis that what is the concentration of alkaloid in the crude drug. Then we will move, these are the basic three types of the alkaloids, which is true alkaloid, proto-alkaloid, and pseudo-alkaloids. True alkaloids are those alkaloids which are derived from the amino acids and they have nitrogen in their heterocyclic ring, like atropine, which is have anticholinergic effect. It's cause dryness of mouth, eyes, and it increase constipation effect and urine retention process, which is anticholinergic properties. And then proto-alkaloids, which is basically not which is basically derived from the amino acid, but it doesn't have nitrogen in its heterocyclic ring. For example, taxol, which is used for treating cancers like ovarian cancer, lung cancer, or breast cancer. Then the third type is pseudoalkaloid. It is not derived from the amino acid, but it do have nitrogen. It is heterocyclic ring. The basic that is common thing is they all have heterocyclic ring, and the presence of nitrogen or amino acid would be variable for its classification. And pseudoalkaloids, for example, caffeine, which have antioxidant and anti-inflammatory process. That's why caffeine, like tea, have a anti-inflammatory effect, and it relieves asthma when we take caffeine or coffee. So these, because I have told you that alkaloids do have any definite physiological activity, like quinine have anti-malarial effect, nicotine have insecticide effect, and morphine have painkiller effect. Cocaine painkiller is a painkiller. Caffeine is a stimulant, CNS stimulant. Aspirin is antihypertensive, and NIMBY is antiseptic, scopolamine, which is used for motion sickness. It's a standard drug used for motion sickness, and pyrethroid, it is a sedative and insecticides. Then preparation of drug for assay. How we will prepare any alkaloid solution for its assay. So first of all, we will grind the drug, extract it to a powder, finest grade. That we will grind, we will triturate, grind it and form a powder of alkaloid that is extracted from any plant. Then the powder will be weighed of bulky crude drug. How we will weigh it? The minimum least count of the instrument or any weighing balance should be 10 milligram if we have to weigh 5 gram of the alkaloidal powder. Then portion of soft extract or ointment. These are maybe weighed on tiered piece of wax paper. We will put our wax paper on the weighing balance with minimum least count of 10 milligram. Its accuracy should be like precision should be 10 milligram, and then we will put our wax paper on it, and then we will tear it, and then we will measure the alkaloid, how many quantity we want to measure. It depends on our preparation, what solution or concentration or quantity or grams or liters of solution we are preparing for our assay. Extraction process, then how we will extract the drugs for alkaloidal drug assay. So there are basically three processes, that is maceration, percolation, and continuous extraction. It is also known as succinate apparatus extraction. So first of all, we will study what is maceration. Maceration, as shown from the term, we will macerate the drug. We will soak the drug in the particular any solvent. It is a process in which we will first crush the alkaloid, and then we put the cellular structure in the Maryum to get soften it and penetrate, and let the solvent penetrate in the alkaloidal crude for like minimum 2 days or a maximum 14 days. By this method, nearly all the soluble content that is soluble in the Maryum will get dissolved or will get extracted from the crude drug into the Maryum or into the solvent that get maximum alkaloidal content from the crude drug to the its Maryum. Maryum is a solvent, especially one used for extracting compound from plant, animals, tissues, preparing and drug, because alkaloid do have a definite therapeutic effect. So we can say that these are the drugs. Like scopolamine is definite drug for motion sickness. Nicotine have basic effects as insecticide, or it can also use for cessation effects for smoking or any drug abuse. Then maceration is different from water because the infusion method and decoctions mostly use water as a solvent. But in the maceration, we will use any organic solvent like alcohol, which get maximum alkaloidal content solubilized in it. And the herbs remains in the maceration for a longer period of time, as much as they can, like maximum for 14 days. And this process do happens at ordinary temperature. But the process of infusion and decoction, mostly we heat or either use hot solvent for this process of infusion and decoction. But maceration is a process that do happen on normal room temperature. So there are basically two methods in the maceration which can be used for extraction of alkaloids. The first method is the drug is placed in a wide mouth container, but we have to close the container so that the solvent don't get volatile. So we do close the vessel tightly to prevent loss of maceration or solvent. The content are shaken or agitated. We continuously agitate or shaken the solvent and with the crude drug in it, so that the entire surface of the Maceration get into the drug to extract alkaloid from it. And this maximum take 14 days or minimum 2 days for the maceration process. And after the specific time, either it's 2 days or any specified drug have like 4 days of maceration, 7 days of maceration, or maximum 14 days of maceration, we will drain the Maceration or the solvent, and then the other process and the other menstruum that is called as mark. We will press the mark to get maximized alkaloid or menstruum extracted from it. It is like that. We press the menstruum to get solvent that is soaked in it to get maximum content from outside from it. Then excess liquid is mixed in and or strained with the liquid and left to stand, that is called as mark. And then we will filter the mark. This is a simple procedure which is showing a simple maceration process in which first we will macerate the drug for 7 days and night or morning, day and night for in the menstruum. Then we will simply strain the solvent from the crude drug, and then this mark, which is the left behind of the crude drug, we will press it to get pressed mark from it, which is also known as expressed liquid, which is get by pressing the mark. Then we'll mix both strained and the expressed liquid, and we will filter it out, and we will then evaporate. Either we can evaporate the solvent to get our alkaloidal content or alkaloidal crystals. Method 2 is a simple like decoction in which we pack the alkaloidal content or drug into a bag, which is a porous bag, to get maximized contact of the menstruum and the drug, and to extract alkaloid from it. And then we will simply settle it for the 4 days to get drug extracted. We will agitate it same as, but the only difference is that we will use a porous cloth bag instead of putting drug directly into the menstruum. And then we will filter it out, and then we will remove it out, and can you reuse the bag. So these are the basically specification for the maceration. How we will macerate, what will be the temperature, how many days we will macerate the drug into the menstruum. So maceration is usually conducted at room temperature, which is 15 degrees centigrade to 20 degrees centigrade, and we will minimum 2 days and maximum for the 14 days. We can use a mouth wide vessel, and we can use a closed mouth vessel. It depends on the solvent, type of solvent, or type of the drug we are using for extraction. Content are agitated repeatedly to get alkaloid maximally get conducted with the menstruum. Examples are like benzoin, tolu, and aloe vera. Then comes the percolation. Second procedure for the extraction of alkaloid, that is percolation. The term percolation is derived from the Latin word per, means through, and calore, meaning to strain. Therefore, the process is which combination of the drug is extracted of its soluble constituent by a slow passage suitable in the column. What we do in this procedure, we simply get a soaken or wetted alkaloidal drug in a vessel, and we pass solvent with a slow process in it, and with this process the alkaloid get separated from the drug with simple gravitational method. Percolation consists is subjected community that is grind substances or a mixture of substances containing in a vessel called percolator to a solvent action of a liquid term as menstruum, in such a manner that the liquid shall extract the soluble constituent and pass through the percolator. So this apparatus is basically called as a percolator, and the process we perform it is called percolation. So this is basically a simple diagram showing the process of percolation. First, what will we do? We took first we will just take a coarsely powdered crude drug. We take a drug and we grind it into a fine powder. Then what we do, we soak the drug or wet the drug in the menstruum, and then we let it stand for 4 hours. Then what we do, we pack the wetted menstruum, that is wetted in the solvent or menstruum, into a, then we pack the all the wetted menstruum in a percolator and slowly add menstruum in it or solvent in it, allowed it for like 24 hours, but the nozzle will be closed. No menstruum will pass through it. Only the mescaline will stay in this percolator. What we will do after 24 hours, we will open the nozzle, this nozzle. We will open this nozzle and the extracted alkaloidal content with mescaline will get released released downside from this percolator. Open and stop the cork, allow the liquid to flow. Then we will to go on adding mescaline and collect it in sufficient time. Like once the after 24 hours we have done uh, the mescaline from it, we add fresh mescaline in it again, and after 24 hours we perform the same procedure to get alkaloids outside from it. Collect the micellar filtered, and we can do process of filtration or any clarification process to get crude or get alkaloid from it. So these are the basically 5 steps we will perform in the simple percolation method. First, we will reduce the size of the drug, that is also known as cumination of the drug. Then we will moisten the drug in the mescaline, which is also known as imbibition. Then we will pack the moistened drug in a percolator. Then we will macerate it for 24 hours. Then we will percolate it like we will drain the mescaline with alkaloid from downside, and we will collect it, and we can evaporate the solvent, and we can use that alkaloid as much as we can, and we can reuse use any other mescaline to get maximum alkaloid content from that percolator from the same crude drug. We can repeat this process in a cyclic way. Then the procedure, what we will use the procedure. The comminution of the drug is packed in a special extraction apparatus terminal to as percolator by packing the outlet with some porous material like cotton. This is the same basic procedure we will following in the last step. This is written in a so I will just read it. Saturate the drug in a specified solvent and allow it to stand for like 5 minutes or 4 hours. Maximum 4 hours. So that was written in that we'll let it stand for 4 hours, but minimum we can let it stand for the 4 or 5 minutes. Add some ammonia sufficient to make mixtures distinctively alkaline that will increase the speed of the extraction process, and from the percolator soluble solvent mescaline is passed through slowly, which dissolves the soluble constituted by of the communication drug. Allow the drug to macerate for 10 to 12 hours or maximum for 24 hours. Then we will perform the percolation. The mescaline is now called percolated, and it is collected from the bottom of the percolator until the drug is completely exhausted of its alkaloidal content. How we will get know that the drug is now exhausted for the alkaloid, or you do have any alkaloid or it don't have any alkaloids? That the procedure we will perform alkaloidal assay or testing to determine either the crude drug or the drug to have alkaloid content in it or not. The flow of mescaline is generally downward due to the gravity that is followed in the percolation process. In some specialized and some sophisticated percolation apparatus, additional pressure is exerted, like we have pressed the mark. Same process, additional pressure is exerted on the column with positive pressure and inlet section to get maximized content out during the percolation process. Determination of the completeness of the extraction, either our drug is exhausted or not. These are the this is test we will perform. Alkaloid test to check alkaloid content. So first of all, what we will do, take 4 ml of fresh last percolate. We will not take the old percolator or the mescaline. We will take fresh last percolate. We will evaporate it or dry all the solvent in it. Then we dissolve in the residue alkaloid in the 0.5 ml of 0.5 normal acid, any acid we can use. And then add a drop of mercuric alkaloid, which is also known as Walser reagent. If the test tube with alkaloidal percolate get turbid, it indicates the presence of alkaloids. Then percolators. We will now study about the percolator. Percolator employed on large scale industrial preparation are generally made up of stainless steel glass lined up with the metal vessels and vary greatly in size and operation. It can be in like for 1 liter, or it can be for thousands of the liter. Percolator vary from size to size. For example, percolator used for extracts from leaf may be 6 to 8 feet in diameter, that it can be so big that it is 6 to 8 feet in diameter, and it is like 12 to 18 feet in height. Like percolator used on small scale are usually made up of glass, and percolator used in large scale are mainly made up of steel. Its shape do vary. It can be cylindrical, roundish, conical, or funnel in shape. So these are the basically some type of the percolators. So first of all, here's the menstruum. Then we will add a wash sand. So the menstruum doesn't get strained in and interact with the filter paper or any washed sand. It do deal with the menstruum. Then we place a filter paper, and then we have drug again, and then we have a glass bowl. And from this, we will open the knob and we'll get the percolate out. This is basically the menstruum, which is the solvent, and this is a crude plant material, which is packed in the percolator, and this is a perfused plate or any filter paper, and this is the drain valve from where we will get the extract. And these are basically the some industrial or large scale percolators, which is made up of the steel. Its maximum is of 100 ml, and this would be like from 1 liter maximum. So here will be the menstruum, and here will be the sand, packed drug, and the filter paper. And from here we will get the drained extract of the alkaloids. So these are the basically like industrial percolators, which might be from like 8 to 6 in feet and 12 to 18 feet in height, and 8 to 6 feet in diameter. 8 to 6 in diameter, or 12 to 18 in feet. So these are the basically industrial percolator which are used on the large scale, which is made of the steel. So there are also two types of the percolators other than the industrial and the lab scale percolators, which are open percolator and closed percolators. For open percolators, which we will use for like for the solvent or menstruum, which is non-volatile, with that don't get volatile, the menstruum don't get volatile, which can be water or diluted alcohol, which can be cheap or easy to handle. And closed percolator is used for that menstruum that are volatile in nature, that like for example IPA, isopropyl alcohol, or ethylene or alcohol or methyl alcohol. So then you have a small activity to study percolators used at industrial scale, which can be continuous cyclic percolators, big large scale industrial percolators, which do perform a cyclic percolation method for the extraction of the alkaloids. Then we study the basic differentiation between the maceration and percolation. Maceration is mostly a time-consuming process. It takes like maximum 2 days, and 14 days. Percolation is a short taking time, like it maximum take 1 day for complete extraction or more. But maceration does not perform complete extraction of the alkaloid from the drug. Not required skill operator. Any layman person can perform the maceration process, but percolation or percolators do require a skill operator to perform extraction. For certain substances which are very less soluble in solvent, are required prolonged contact of the solvent. It is time consuming and take a large number of days, like 2 days maximum minimum and 14 days maximum. Special attention should be paid on particle size of the material throughout the process. So we can grind the alkaloid drug to a fine powder to increase the time, or decrease the time, or increase the processing of this percolation method. Suitable method for a less potent drug, which are cheap drug, but percolation would be used for the potent drug and that are costly drug. Third and the last type is the continuous extraction. Oxidant apparatus would be used in this process, and this would be a continuous extraction process. And here the process of extraction and the process of evaporation will get combined, because in a oxidant apparatus, extraction and evaporation do happen at the same time. So in the oxidant apparatus, condensation, evaporation do happens in a cyclic method to exhaust the drug and to get maximum alkaloidal content out from it, or get maximum alkaloidal content extracted. Thus, with help of the temperature, smaller volume of solvent may be used. We can use a small amount of the solvent to get extracted alkaloid from it. It is used in penetration of the menstruum in a cellular tissue that it is very slow. Quantity of menstruum is very less, like we are using an expensive solvent or solute is not readily soluble in the solvent. If the process of solubilization of the menstruum into the drug is slow, then we can increase the process by adding heat in it using oxalate apparatus. In this case, small volume of hot menstruum is passed, hot solvent is used, and it is passed from the crude drug again and again to increase the process of extraction. And this is called oxalation until the drug is exhausted from its active alkaloidal constituents. What is important, the volume of solvent is used again and again. So we can call it a solvent recycling or menstruum recycling process. Procedure which is followed is very simple: moisten the drug with the specified solvent, then we have to allow it to stand for the 5 minutes, and then we have to pack it in. But before packing, we have to alkaline the drug using ammonia to increase the process of alkaloidal extraction. We will always use alkaline media or acidic media to increase the process of alkaloidal extraction. Another drug to macerate for 6 to 12 hours, then we will allow the menstruum to get in contact with the procedure, and then pack the drug in a thimble. In its thimble, this is called a thimble, and cover it with the pledge of the cotton, and take the thimble and insert into a suitable extractor, which is also known as oxalate extractor, and then add sufficient quantity of solvent and extract the drug using oxalation process. So what will the procedure would be followed in the oxalation apparatus? This is a thimble with packed alkaloidal drug in it. So we will get it attached with the siphon. This is the siphons. We will get attached the siphon with it, which is already attached, and we will use a flask in which the menstruum or solvent will be present. This is the siphon. This is the table in which the drug or the crude drug is packed, and this is the condenser, which will recollect the hot menstruum back into the flask. Flask is a menstruum which is get boiling. This is a hot plate which continuously boil the menstruum. Menstruum will get then pass, hot vapors will get into this, and that we will go toward this, and from this the drug will get extracted, and from this procedure the menstruum will get out from like this tube and this tube and this tube, from this tube and into this. So the menstruum with alkaloidal content is there into the flask. The extraction chamber in which the drug is filled and fitted with a tube and a siphon. Siphon will get the vapors and the alkaloidal content back into the flask. So now here what will happen, the alkaloid will get condensed in the, get collected in the bottom due to density, and the vapors will again form of the same menstruum because they are because we are continuously heating it, and the condenser. And what happened in the condenser, the hot vapors will collect here, and the water will cool the menstruum again, and it will form the menstruum again. They will pass through the side tube, enter in the condenser where they are condensed, fall back into the packed drug and extracted chamber. Percolates are extracted out of the active constituents. Alkaloid will get extracted into the, as the volume of menstruum is extracted, increase the volume, siphon will increase till it fall back into the flask. Second, then what will happen further? Heating vaporize the menstruum, active alkaloid remain behind the flask. The active alkaloidal content will remain in the alkaloid, but the menstruum will be get evaporate again and get condensed again and evaporate again and condense again, and will extract the drug in it. Extract the alkaloid with this same procedure: heating and condensation, evaporation, condensation, and extraction. This process will be doing combinatorially or combined processes. Filling and empty of the extractor goes on continuously, and the process is repeated like 14 to 15 times through the drug until the drug get exhausted. Disadvantages: we cannot use this process for a thermolabile alkaloid. If we can use it for the which are thermophile, how much pressure we get it, how much temperature we get it doesn't get damage the alkaloid. So oxalate apparatus, this is simple oxalate apparatus. This is the like flask which with the alkaloidal content and the menstruum. This is the siphon tube. This is the thimble with L drug in it, and this is the condenser which condenses the vapors back and menstruum vapors back into the menstruum. Cool. And the process of extraction will be done here. The menstruum and the process will continue. Extraction chamber, siphon flask, heating hot plate, water outlet, condenser. Purification of the alkaloid. Alkaloid solution obtained by any of the extraction method is usually contaminated with other extravents. The process of solvent extraction is done by the menstruum. A lot of other other contents are also solubilized in the alcohol. So we will perform quantitative determination of the alkaloid, and we will remove the contaminants from the alkaloid. For effective purification, the process will be used, and the process is defined here. Remove the alkaloid from the immiscible solvent and by shaking with an acid. We will remove the alkaloid from the immiscible solvent which is in water, and we will shake it with acid. We will shake it with acid. First, for the extraction process, we were using base alkali, and here for purification we are using acid. Then make the acidic solution alkaline with an alkali hydroxide and extract the immiscible solvent. Then we will add alkali in it, alkali hydroxide, sodium hydroxide. The volume and strength of the acid vary case to case. However, total volume should be small as possible. Small volume of acid should be added. Shake the combined acid extract with 1 or more 10 ml portion of the apparatus immiscible solvent until the acid solution is clear. Then wash the immiscible solvent extract with 1 or more 5 ml portion of the water acidified with HCl and H2SO4. We'll purify the drug with the help of HCl or H2SO4. Then make the acid solution alkaline with ammonia and extract it from immiscible solvent. Immiscible solvent in which the alkaloid will be immiscible, that is water. Repeat the operation as long as the alkaloid is extracted by the immiscible solvent. Alkaloid will be totally extracted from the immiscible solvent into the solvent in which it is solubilized. The completeness of the extraction is tested by using mercuric iodide test. Mercuric alkali test is the same test we performed here. Let me get it back. Here, mercuric iodide test was a reagent in which the turbidity shows that drug is not exhausted from the alkaloid. So we will perform the same procedure here of mercuric alkaloid. In all assay, continue the extraction until the 0.5 ml of the last acid washing show a slight turbidity or no turbidity. Until the turbidity concentration get lower, we will redo this purification process until all the alkaloid is purified from the process. So these are basically some tests or some assay which are performed in alkaloidal solutions or extracted menstruum. And variable reagents will be used that form precipitates or either coloring agents for the recognition of the alkaloids. Alkaloidal precipitation reagents are the Myers reagents, which use potassium mercuric iodide solution. Then comes the Wagner reagents, which use the iodine and potassium iodide. Then come the Dragendorf reagent, potassium bismuth iodides. Then we use the alkaloidal coloring agent, which is mercury reagent, formaldehyde and sulfuric acid, Mandelin reagent, sulfovanadic acid, and Erdmann reagent, nitric sulfuric acid. Determination of alkaloids. So this will be the procedure we will use for the determination of alkaloid. Evaporate the solution of the purified alkaloid in its immiscible solvent to dryness on steam bath with current of air. We have to evaporate the menstruum or the solvent from it using an immiscible solvent, using any steam bath. Then soften the alkaloid residue by adding about 1 ml of the neutralized alcohol or ether. Then we will add acid in it and we will warm it and dissolve the alkaloid residue into the chloroform. And in that chloroform residue alkaloid, we will add acid of higher molarity, and then we will remove the or evaporate the chloroform from it, and then we will add quantity sufficient of the water in it to make it volumes up to like 25 ml, and then we will perform titration process with the stunned alkali to get the quantity of the alkaloid that is present in the mixture. Dry the alkaloid residue at 105 or at a constant weight. 105 degrees centigrade will be used because mostly the alkaloids are non-thermolabile and they can withstand the temperature. Activity would be that we have to study like Meyer test. In the Meyer test, I will tell you one by one. Meyer test. In the Meyer test, potassium mercuric iodide solution is used, and the presence of alkaloids gives cream color, white, yellow, or green precipitates. Wagner reagents or Dragon-Roth reagents, in which we use potassium bismuth iodide, and by adding potassium bismuth iodide in the Dragon-Roth test, orange color precipitate shows the presence of the alkaloids. And the third is Wagner's test. In the Wagner test, we use solution of iodine and potassium iodide, and the red-brown precipitate or reddish-brown precipitate shows the presence of the alkaloid. Then the tannic acid test. In the tannic acid test, we use tannic acid solution, 10% tannic acid solution, and buff precipitate will form, which shows the presence of the alkaloids in diluted acid. Then melting point range, all alkaloids do have a defined range of melting point. Like atropine do have a melting point of 10, 1A14 to 118 degrees centigrade, which is the range of a melting point. So these are the basically some tests. We will recap it. These are the precipitation neutralize acidic citric acid basic using heavy metal iodides for like caffeine. We have used this for caffeine. A purine derivative does not precipitate like most of the alkaloids. So we are using alkaloid like Dragon-Roth, Mayer's, Wagner's, and Hager test. Mayer test, in which we use potassium mercuric iodide solution. It forms green precipitates. It shows the presence of the alkaloids. And then the Hager's we use picric acid, and it forms yellow precipitates. These are the yellow precipitates which show the presence of the alkaloids. And then the Dragon-Roth orange colors precipitates. Here we can see the orange color precipitates. This is orange color, and this is the orange color precipitates which show the presence of the alkaloids. And we use potassium bismuth iodide in the Dragon-Roth reagent. In the Wagner reagent, we use iodine and potassium iodides. And here is the red-brown precipitates. Here is the red-brown, or here is the red-brown precipitate which show the presence of the alkaloids. Estimation of alkaloids, Meyer test, it gives white or yellow precipitates. In the purine, expects the alkaloid of the purine group. Purine group alkaloid do not show white or yellow. It gives green precipitates. Then Dragon-Roth, which goes yellow, orange precipitates. Wagner's gives brown or reddish brown. Hager, it gives crystalline precipitate. And it gives insoluble precipitates. Then melting point range like atropine get melting point range about 114, 114, and 118 degrees centigrade. Then these are the basically code for the 12 types of the alkaloid that is A, I, P, 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 Q, S, T, T. A, triple I, quadruple P, 1Q, S, and double T. Alkaloidal amines, indole alkaloid, isoquinolones alkaloids, imidazoles alkaloid, phenyltherine alkaloid, pyrrole and pyrimidine alkaloid, purine alkaloid, pyridine and piperidine alkaloid, quinolone alkaloid, steroidal alkaloid, tryptamine alkaloid, and terpenoidal alkaloids. So these are the Mayer's test, and this is the control which gives yellow color, but this is the precipitate deduction of the reagent from the plant extract. It gives precipitate. It's only yellow in color. It gives yellow precipitate. This is a Wagner test in which we use iodine and potassium iodide, and it is only red, and it is giving red-brown reddish precipitates. Any degree of the turbidity or precipitates in any test tube considered as positive results. Degree of turbidity we can indicate like from 1 plus sign gives a slight turbidity, low concentration of the alkaloids, plus plus gives more turbidity, and plus 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 three triples positive shows heavy precipitation and heavy alkaloidal contents. So these are the drag and drop tests which do perform in the filter paper. And these are the actually the positive results which is giving us the yellow orange precipitates, and this is the negative which is not giving us the precipitates. Thank you very much for listening that far too much. Here's our first topic of alkaloidal drug assay finishes. Thank you so much.